So when we think about the mechanism of action of anti-epileptic drugs, we want to think about, okay, first of all, what's happening in the brain, what's happening with the neurons, what's happening at the synapse. And the simplest way to think about it is too much activity, not enough inhibition, right? So we have too much excitatory activity, and what neurotransmitter is the main excitatory neurotransmitter? Exactly, glutamate, right? And not enough inhibition. What's the main inhibitory neurotransmitter? GABA. And so when we think about designing drugs to prevent that excess activity, what we want to do is stop the glutamate activity or increase the GABA activity. And what you'll see with all the drugs that we're going to look at is that there are multiple ways of doing that. So you can decrease the number of action potentials that are happening here. You can decrease the amount of calcium that's able to come in. You can decrease the activity at the receptors, or that's for the glutamate, right? Or you can increase the GABA release or the activity at the GABA receptors. And some ways to do that are to inhibit the voltage-gated sodium channels so that you're going to prevent the action potentials. You can inhibit the voltage-gated calcium channels so that you prevent the release of the neurotransmitter. And then, like we mentioned, you can increase the release of GABA, or you can inhibit the glutamate activity on these postsynaptic receptors. So many different ways that we can do it. We can do it presynaptically in the action potential, presynaptically in these voltage-gated calcium channels, or postsynaptically by increasing the availability or activity of GABA and decreasing the availability or activity of glutamate. And so what I'd like you to do right now, I want you to either number or letter these 4 different actions. So you can either put this one as number 1, number 2, number 3, number 4, or if you prefer letters, you could do A, B, C, or D. And then I want you to think about, okay, this class of drugs is doing this. Was that number 1, 2, 3, or 4? The benzodiazepine is doing this right here. So for the ones that are listed on this image, go ahead and indicate whether they are inhibiting voltage-gated sodium channels, voltage-gated calcium channels, GABA activity, or glutamate activity. Okay, and hopefully what you were able to see from this image is that these 3 are going to inhibit the voltage-gated sodium channels, so that's going to be number 1 or A. These 2 are going to inhibit the voltage-gated calcium channels, so that is going to be number 2 or B. And then the benzodiazepines and this tiagabine, I'm not 100% sure how to pronounce that, and this one over here, all 3 of these are going to increase the GABA activity, doing it in different ways. By this one binding and activating the receptors, this one preventing the reuptake, and this one is going to prevent the breakdown of GABA. So that GABA transaminase, I believe, is going to break down GABA. So if you're inhibiting that, then GABA is available more. So all 3 of these down here are going to increase the function of GABA. Now, there are some, they aren't actually listed here, but they're going to inhibit some of the glutamate receptors and prevent that signaling. And one that we didn't really talk about, but valproate. So valproate is the one to use with caution, and we'll see moving forward in many different places because valproate does many different things. It has multiple mechanisms of action, and it is teratogenic, which means it can cause birth defects. So basically, any female of childbearing age should not take valproate, and we'll highlight that moving forward. But that's why it's not identified in any one of these things, because it does multiple of them. And just in case it comes up in the future, it's also known as valproic acid. And so now, moving forward, what I want you to do is try this on your own. And I'm going to trust you to recognize that I know how learning and memory works, and that you trying it first is going to give you a better understanding of it, and you're going to remember it more for the long term instead of just listening to me and write it down. So, mutual trust here in that I will give you the right answers, but I am trusting you to practice this first on your own and see if you're able to understand it from the images that you're going to be given. All right, so in general, what I want you to do, you'll notice that in your handout, the next pages, actually your handout looks more like this. So this image will be here, and you'll have this table. And what I want you to think about is say, okay, this phenytoin is right up here, and it looks like it's doing this. So what is its general mechanism of action? So in that one, we'll practice together. I will model, and then I expect you to be able to do the rest. So for this one, this is going to be a sodium channel blocker. So phenytoin, sodium channel blocker, right? We did the first one together. Your general mechanisms are going to be the ones that we talked about up here. In my key, I have written them just a little bit different. So inhibit voltage-gated sodium channels, I just have sodium channel blocker. For this one, I have calcium channel blocker. For this one, I have GABA potentiation, which just means increased GABA activity. You don't, just however you want to do that. And this one would be to block glutamate receptors. There is also a couple of them that have multiple targets, or a couple of unique targets. But let me see, in mine I only have two that have multiple targets, and then one that has a unique target. Everything else fits into one of these 4 categories. So one of those 4 categories is going to go in this general mechanism. I do not expect you to get into the specific mechanism, because there are different ways that they can do, these channels can be blocked, and so I don't expect you to be able to go in and do these. I will also say that I'm noticing that there are a couple that are not listed in these 2 images, so you might have to Google those, but it's not too bad. I think fentobarbital is one of them. Can't remember the other ones, but there are a couple that aren't in there. But Google it, figure out what it is. Then, when you go to watch the next video, I will give you the answers to those general mechanisms, and we'll talk about the specific mechanism for each type of drug as well.